This forum came about a few months ago when Barry Boulton was here for, I guess, another forum that he just attended, and then he came up and someone told him I was on the program committee, and he came up and said that he had a presentation he could give us on evolution using videos of birds in particular to illustrate various aspects of evolution. So I immediately said, please, please, if you would agree to give that talk, that'd be wonderful. So he fortunately did, and he came all the way from the Sierras yesterday. He lives in the Sierras, so he came a long way to be here. He has a place to stay, I guess, last night and tonight, so that's good. But anyway, I appreciate him coming all the way from the Sierras to talk to us today. I'll just read the summary here. The title of his talk is Evolution, Adaptation, and Bird Behavior. A video presentation. The basic evolutionary principle is elegant and even simple, but its application in human evolution is controversial, to say the least. However, viewing bird behavior in video sequences allows us to more objectively analyze evolution and adaptation in a fellow creature, and then to hypothesize its application to human evolutionary drivers. Barry Boulton combines a passion for bird behavior and practical evolution using high-definition video as the primary medium. So please give Barry a warm welcome.
Thank you, Brian. That's very kind of you. This is actually the responsibility of Carlos, because he was the one who first went to Brian and said, hey, somebody should give this talk on birds. So Carlos, you're responsible, but this is a good responsibility, I hope. Let me give you an introduction or a background to what I'm doing. I joined the Audubon Society up in Sonora, actually, Central Sierra Audubon, about 8 years ago. And soon after I joined the board of that organization, the local county newspaper emailed our president and said, we're doing a new version of our newspaper. We'd like somebody, or we think it would be nice if somebody would write a weekly article on birds. And so as a neophyte in birds, I thought, well, that's a great way to learn what birds are all about. So that's exactly what I did. So for every week for about 3 years, I wrote articles on different birds. So I had to do a lot of bird photography because you want bird photographs to go along with the article. And I did a lot of research with the Cornell Lab of Ornithology, and I learned a lot about birds. I also learned that there's a lot we don't understand about birds, which is really interesting because that gives you an opportunity to begin to think yourself what's going on. And at the same time, I was getting involved in serious videography, so I wanted to combine the skill I was developing along with the passion I had for birds. So these days I take very few photographs of birds. I take almost exclusively videos. And then at the same time, I'm really fascinated by evolution. I've been fascinated by evolution for a while, but now as I watch bird behavior and I think about what they're doing and why they're doing it, and necessarily I think about evolution and the adaptive causes that makes them do these different things. So I'm going to go through this, and if anybody has any questions, I think you can ask them, or comments. We can do that during the presentation. The straight video is only about 39 minutes long, but we probably won't get to the end because I'm going to stop at different points and tell you things, but it's going to be interesting all the way through for you, I think. Well, I think one of the interesting aspects of birds and animals in generally is their emotions. What does it all mean? You know, it's only 200 years since the thinking people said that animals and birds have no feelings. It's okay to do whatever you want with animals and birds. They had no feelings, and I suppose it's a justification for only humans having a soul that will go to heaven. The animals, if they had feelings, they might have personalities and they might have a soul, and now you have a real problem from a religious point of view. But you know, when you look at birds and you look at animals, I'm looking at birds, you can see there's emotion, there's feelings. I was in the Baylands at Mountain View, San Antonio Road, the day after the first big storm of the season, which is a great time to see birds. And what's interesting is this little juvenile had never seen a puddle before, never seen a storm before, but it knew what to do. And the interesting thing is how pleasurable this appears to be. Now, I don't know what a bird really looks like when it's feeling pleasure, but it looks to me like it's having pleasure. So I began to think more and more deeply about the emotions of birds, and you'll see some different emotions. But one of the words that struck my mind and gave me a lot of thoughts, and I have a friend in Berkeley, we talk about these things all the time, was the word like. We like things and we don't like things. Is there an adaptive advantage to having the ability to like things? Well, it's interesting. All creatures love two things: sex and food. If we don't have either of those two, we don't survive as a species. So, by the way, this is the adult. You see the golden crown. The immatures don't have that because they need to be fairly cryptic, in other words, camouflaged, so they're not open predators. So I want to stop. So the word liking, I thought, was a real interesting thing. What is the adaptive advantage of liking things? As I said, there are critical things we like, the sex and food. And I thought about this for a long time because, I'll give you an example. I was in a canyon about a month ago, and I saw 4 ravens. They were flying beautifully up in the air, and I was thinking, what are they doing? What's going on in their minds? You know, what are they doing? They weren't foraging, they weren't courting, they weren't doing anything like that. And I realized, you know, birds like to fly. I mean, that sounds odd, but birds like to fly. And if you think about it, if you're gonna be a flying machine, you have to be really good at it, and you don't just do it when you need to get away from something or migrate. You have to practice all the time. And what makes you do it all the time? You like it. And if you think about the adaptive advantages, if you compare us to, you know, this group here, every one of us, probably every one of us, with the young people who love to exercise, you imagine if we were in a survival situation, they would survive, and we wouldn't. Well, I know I wouldn't anyway. You might have a different point of view, but I know a lot of us wouldn't survive because they like to exercise their fit. So liking seemed to me to have a really powerful adaptive reason for being. So we can see the emotional opposites: aggression. If you go to the Baylands, you'll see this silly old coots, and it's interesting. That's a very, very social species, but boy, do they fight each other, and they'll kill each other. They'll use their claws, and they'll actually kill each other in the fight for a mate. And you see how the guy turns his back to prove he's strong, he's powerful. That's the way you get a female. Is you impress them with the fact that you're almost invulnerable, you're confident. That's exactly what they do. I think the large one was the males who's intimidating the females. And I don't know why these males have to intimidate females, but as we know, that's not an uncommon characteristic. So you see the similarities between us and these birds, I think, is pretty great. This bird, the great-tailed crackle, is actually an invasive species that's coming up from Texas and Mexico. But what you'll see is it's smaller than the crow. The crow you'd think could defeat it, but this little bird is so aggressive that it actually takes the food away from the crow. It's really amazing how it does it. But you'll see later on, it walks by a gull. And it does, although it wants to take the food from the gull, it doesn't dare because the gull would make mincemeat of it. It'll be interesting to see that. So it didn't catch that shell. Somebody got that shell. Another bird got that shellfish out of the pond. This is by the Brinkstorff house in Mountain View, as a matter of fact. There's a pond there which you may be familiar with. So it's interesting, we regard birds as having a particular diet. You know, sparrows, for instance, eat seeds and so on, but all birds are really quite opportunistic. They eat their normal food, but they're like us, they'll enjoy other food too. Now, Now, I don't know if you've seen this bird, but this one was shot by Lucia at the VA hospital in Menlo Park, about 2 or 3 years ago. The cedar waxwing, and it's called the cedar waxwing because these red dots are actually like wax at the end of the feathers. And you'll see this one has 7. Now, if you're a cedar waxwing male and you have less than 6 of these, you're not likely to find a mate. The females know the difference between a mature and an immature one. So if you've got less than about 6 of these pieces of wax-like substance on them, you don't get a mate. And interestingly enough, because the immatures don't know how to look after their young too well, if a female marries, people use marry and divorce in birds, it seems strange, but they do. If a female chooses an immature, the chances of reproductive success are not so great. They don't produce so many young. So the females know which ones to go for, and they're always looking for the mature males. Now that particular, let me turn that down. This is in Murphy's Main Street. I was telling Brian there are rumors that I've moved back up to Murphy's because there are 22 wine tasting places in Murphy's, but I deny that. Anyway, this is an interesting bird, the cedar waxwing. It's what's called an eruptive species. There are species that migrate to regular places every year, roughly the same places every year. But there are eruptive species that they go wherever the food is that they want. So in this case, the cedar waxwing is a fruit and berry lover. So they tend to move where there are fruits and berries. And talking of eruptive species, you may have read in the newspaper this year about snowy owls, which have been seen. The snowy owl's white, so it's an Arctic bird. But so normally you see them in northern states. But this year they've been seen down as far as Florida. And the reason is that there's been an eruption, and the reason behind the eruption is that there have been so many lemmings, which is their favorite food, their sole food actually, that their reproductive success has been great. So there have been an awful lot of snowy owls. They have to go somewhere to get food. So they've eruptively moved across the states, on the eastern side of the states, even as far as Florida. So you imagine a white snowy owl, an Arctic bird in Florida, is sort of something to see. So these birds love in this case, the persimmons in Murphy's Main Street. You'll notice they all feed on the same one. They don't feed on different ones. They seem to congregate, and you'll see all this social species. There'll be a little bit of aggravation in here. I mean, even social species have their. You'll see that quite amusing the way they need to do that. But other birds, as I mentioned, like the seed eaters, also find this stuff, fruit, attractive on occasion. And they have adapted different. Pardon? That's persimmon. I should tell you, by the way, that some birds have different digestive systems. So the sparrows, for instance, will eat the seeds, but the cedar waxwing eats the fruit itself, but not the seeds. So in fact, it's a great seed disperser because the seeds go straight through, and of course they disperse them all over the place. So there's a sort of a symbiotic relationship between the fruit and the cedar waxwing. So birds opportunistically eat fruit when it's available, and you'll see here even first-year juveniles, never seen a persimmon before, copies the adults and does the same thing. And as you'll see a bit later on, learning is quite an interesting proposition for birds, because every young bird has to learn how to fend for itself and live. So this one's obviously seen its adult sparrows or watched the cedar waxwings eating. And the red-breasted sapsucker, lots of birds do this. Now this is an interesting bird. You know that most birds have plumage dimorphism. In other words, the females and the males are different. But in this case, they're both the same, which suggests that they're monogamous, because males have stronger plumage generally because when they're going to fight each other for a female. So if they have the same plumage, they're going to be monogamous. Now so it's called a sapsucker because what it does is it drills holes in living trees, not dead trees, but living trees, because it wants the sap to come out. It eats the sap. It also eats the insects that get stuck to the sap. So now, but then we have cases of kleptomania. So for instance, the rufous hummingbird will actually nest near a sap well or a set of sap wells that are being excavated by sapsuckers, so it can go to the sap and eat it, and it will actually follow a sapsucker around and steal from it. So birds learn how to maintain the maximum amount of food. So there are several others that do that you may not think about. This, I think, is probably the most beautiful, one of the most beautiful woodpeckers, the Nuttall's woodpecker. And see, this one has got this is a male because it's got that beautiful red patch on the head. See, the female does not have the red patch, so that's how you can tell it in that particular case. And the downies are slightly smaller. Now, these are interesting. You saw that the male and the female Nuttall's woodpecker, they actually feed on different places in the tree. See, birds want to not compete with each other if they can avoid it. They want to find a little niche where they don't get competition. So actually, the male feeds for insects and bits and pieces on the larger trunks, and the female on the smaller trunks. So they're not competing with each other. That's an interesting thing that a lot of birds do. The male and the female tend to feed in different places, forage in different places. And here's a little warbler that does the same thing. This thing's got a yellow mark on its plumage around its butt, so it's called commonly butterbutts. Now, let me tell you before I show you what I'm going to do here. I've often thought when I look around at birds, I see them looking around to see if there's a predator around. They're always looking around. And I always thought, isn't that so stressful? How do they manage? We don't deal with stress that well, but they seem to be looking around all the time. And I was listening to a series of lectures by Robert Sapolsky, who's a neurobiologist professor from Stanford, and he says something encapsulated the answer for me, and you probably know this, but I never thought about it before. And I'm going to paraphrase, but what he simply said was that stress is a call to action. And I thought, so I suddenly realized the birds aren't stressed when they're looking around, they're stressed when they see me close to them taking videos or something like that. But what does a bird do when it gets stressed? It takes action. It flies away. Now, they're not like human beings where we take the stress and we go home and we beat up on our family or something like that. No, they take action and it's done. And they don't stand there and think, oh God, I should have moved earlier, or I could have hung around longer. No, they did it right, and they get reinforced in what they did. We talk a lot about human beings and our reinforcement techniques. When a bird makes the right choice and it survives, it's reinforced. So then it makes me wonder, do they have such a thing as self-confidence, self-esteem? I mean, do those things go on? We don't know. But certainly their behavior is reinforced. This is our third largest woodpecker in the US after pileated and another one I've forgotten. And it's interesting, it excavates quite a large hole, but it's not really a very great excavator, not like the pileated woodpecker. Now its primary food is ants and beetles. And you'll see this one has great problems with a larger worm as it goes on. And I think it's a juvenile. I think it's a juvenile for two reasons. One is it was having troubles eating a worm. I can't say I blame it, but anyway, it ought to know better. But it will learn. And also, I think it's a juvenile because it wasn't scared by me, though I had a camera with a fairly long lens, but I was fairly close. And the adult birds are always more nervous than the young birds. The immatures haven't learned. They ought to be a bit more careful. And they look around because there are birds called, there are two predator birds, the Cooper's hawk and the sharp-shinned hawk, that will swoop down out of the tree and lift these birds off and kill them and eat them. So that's why they're always looking around. Of course, they're always concerned about coyotes and bobcats and things like that, if you go back far enough. This was taken up in Memphis, and you can see this is a male because it's got red. If it was for a female, there would be no red coloration on that bird. Now here's a really stressful situation. Normally you see smaller birds harassing a larger bird. It's quite common to see that. On this occasion, the raven was actually chasing a kestrel. Now that's interesting because a kestrel is a very small, very maneuverable predator, and you wouldn't think that a raven would bother to do that. And I thought the raven was actually going to catch it a couple of times. But I suspect the raven got really tired doing this, because that's really tough for a big bird to be doing that. And he was lucky actually, because I think his ego was saved. You know, I think that, but I don't know if that's true. But I think his ego was saved in this sense. He was doing that, and his mate came along, and he swooped down to see his mate. And I think she probably said, "Well, that's enough of that," something along those lines. I was in a canyon, the one I mentioned about 2 or 3 weeks ago, and I saw this little bird called the Ruby-Crowned Kinglet. They're actually very, very quickly moving around, these birds. They're always in foliage. And so I had my smartphone with me, so I played the song that I got for this bird, and I got really stressed. I got really stressed for 2 reasons. One is it hears a competitor's song, and secondly, he couldn't see it. Oh, and actually, thirdly, it's because it's on my smartphone, so it looks around, it can't see it. That's a really stressful situation for a bird in its territory. And on top of that, birds recognize local dialects, or lots of birds recognize local dialects. So it's a call, it's not a local dialect, there's something wrong here. If it's not a local dialect, then it's really an intruder, and it can't see the intruder. So this bird got really stressed. I've got two short segments here. One is, you'll see it looking stressed. You'll hear it stressed. It's actually its own song, but the sound and the vision are not synced because I recorded it slightly separately. And the second half, you'll see and hear it singing its. It won't be it's singing its courting song, which is quite a beautiful courting song, but you'll see the difference between its I'm concerned song, or its I'm concerned buzz, and the courting song when it wants a female. See, it's really concerned now. And it always flips around like this. It's always been difficult for me to get a decent photograph of this thing because it moves around so fast. Now, it was so stressed that it actually sat there. That's an incredibly unusual thing to do. To see one of these birds sitting just like that, so you can tell how stressed it was. It was actually seriously looking to find out this competitive territorial interloper. But so I had to turn off my smartphone and to leave it alone because you don't want to stress birds too much. But I went back a week later and it was still there, so I knew it survived my transgression. We advise people not to do too much, this is a matter of fact. Now you know that when birds are hatched, they don't have too long between hatching and being self-sufficient. They've got to be self-sufficient in a very small number of weeks, so they have to get fed an awful lot, but they also have to get trained by their adults. And you'll see, this is a northern flicker again. I took this over at Mono Lake, and you can see the tree has been stripped by a lightning strike, so this northern flicker had excavated this cavity. And you can see how desperate these youngsters are for food. Now, let me just tell you something interesting here that I don't fully understand yet. What happens is the adult goes and finds ants on the ground. You'll see ants in the trees, they ignore those, but they get ants that they dig for in the ground. And they bring them back, and they have a crop full of these ants, and then the youngster has to encourage the parent to regurgitate to bring them out. But what I don't understand is the adult's actually got his bill inside the youngster's bill, and I don't know how that makes the regurgitation happen. But that's what's going on. You'll also notice how the adults here are very, very worried about intruders. They keep looking around to see that there's not being watched because they don't want the location of their nest to be disclosed to another bird that might predate, like the Cooper's hawk or the sharp-shinned hawk that I mentioned. So very nervous. That's a female. You see no red on the head. Now here's the thing we don't think about. Birds have to keep their nest clean, because when the nestlings come out with no feathers or anything like that, they're pretty vulnerable to microbes and so on. And so what happens is that they actually defecate in little sacs, if you will, and the adults have to take the sacs out. Now, in some cases, birds will actually the adults have to prompt the youngster to defecate so they can take it out and clean it out. So maybe for 10 days, the adults have to do that. So they're constantly bringing food in and taking out the fecal sacs. Then after a while, the youngsters get able to defecate out through the hole, because they don't know what, sometimes they miss. But anyway, that's the general idea. So this is a she. She'll take it off and drop it somewhere away from the nest. Not too close to the nest, because that gives an idea of the nest being available, being there. You see those ants there? So they don't take those. But when I've been watching these interactions between the adult and the youngster, I've been thinking another thing. The adult has to teach the youngsters to become self-sufficient, to go out themselves, and they don't like doing that. You'll see some examples in a minute of birds that youngsters really don't want to be weaned off. And I have a sense that maybe the adults are making it a little bit difficult for the youngsters to get this food, so they know they have to work. That's what I suspect. I did the thing that videographer hates. I lost the original, so I don't have any original video sequences, so I don't have any sound. Now, when you look at that hole, you can see that takes some work to do that. That's really tough, and so we know woodpeckers have adaptations. This is a pileated woodpecker. I watched one on Friday in Big Tree State Park in Calaveras County, and it was not too far from me, about as far as I am from Hilton, and it was excavating on a sugar pine, and the chips were going everywhere. And I was thinking then, how do these birds ever do that without knocking themselves out? It's really amazing. So so if we look at the problem, you look at that 20 feet a second or something like that is what the speed with which the bill is hitting the wood. So we're getting 1,000 to 1,500 G's impact force. And this can go on for some hours a day when they're really building these things. It's reckoned, by the way, that if you can survive a car crash, you probably, a really bad car crash might be 100 G's. It's about the maximum 100 that a person can withstand, about 100 G's. So we're talking about 10 to 15 times more than that. So the question is, how do they do that? Well, there are a number of things that go on. One is that all birds actually have a much increased ability to withstand these sorts of blows anyway, because their brain mass compared to their area is much, much less. So any impacts distributed over a larger area, relatively speaking. So it's reckoned that a bird can withstand maybe 50 to 100 times more than a human being's brain can in terms of blows. So all birds tend to peck. So all birds have this sort of feature. It's just that the woodpecker's got some other adaptations too. And by the way, if you've ever had a bird hit your window, your house window, and many times they generally seem to survive, whereas we might think they wouldn't survive. They get up, they shake their heads, and off they fly. And the reason, and I think the reason is, this is one of the advantages they have, that they have this brain that's got less mass to area, so it's much more robust than a human's brain would be. But I have to tell you, my previous house was up in Arnold, and it was on a slope. So the back side was quite high, a good 3 stories, maybe 4 stories actually. I was having it painted on one occasion, and the painter came out the door and said, "Look what happened to me." And he had this pileated woodpecker. The pileated woodpecker had hit the window at the top, and incredibly so, it fell down and hit him on the head. Would you believe that? What an incredible coincidence. But it broke its neck, I'm afraid. So yeah, it was a shame. So there are several adaptations. This is one adaptation that woodpeckers specifically have. The skull is extended, and over the upper mandible there's a lattice structure that absorbs some of the stroke. And I should tell you, with birds, the upper mandible is the one that moves. In our case, it's well, we don't call it mandible, but it's our lower jaw that moves. But in birds, it's the upper mandible that moves. Pardon?
Could you please spell auto mandible?
Wait for the mic, please, huh?
Upper mandible.
Yes.
M-A-N-D-I-B-L-E. Yeah, we don't call ours mandibles, do we? Yeah. So now this one's not a very, as I mentioned before, this one, although it excavates holes, is not one of the big, really big excavators. So the pileated woodpecker would have a much bigger part above that upper mandible. So that's one of the things. The eye has a, you think about it, when it hits, the eye is going to be moved around. So the woodpeckers have a third eyelid that helps to keep the eye in place. And I think there may be something to do with the veins, the blood vessels in the eye too. I don't know. But those are sort of adaptations that they have to withstand that force. Now, John Muir had a favorite bird, at least so it said he had a favorite bird, the American dipper. It was called the ouzel in his days. I actually think it was not his favorite dipper. I think he's more like me. My favorite bird is the one I'm looking at right now, you know. But this is a fascinating little bird. If you haven't been up to Calaveras or Tuolumne counties, you should go up to this place. It's the middle fork of the Stanislaus River. And it's a perfect habitat for an American dipper because it's fast-flowing mountain stream, clear and clean, and it's got lots of insects and insect larvae in it. And this is a fascinating bird. It's called a dipper. As you'll see, it dips up and down, and you wonder what on earth is going on when it does it. So this is a really beautiful habitat up here. I spent many an hour up there. I just enjoy it. That's not its song, it's one I got from Cornell, but you'll see it bobs up and down. We asked why does it bob up and down? Well, we know for one reason it's a communication method, because in a very, very noisy environment, it has to communicate in different ways. So this is a high-pitched song that, I want to stop there. This is amazing. It's got eyelids with feathers on it, and the feathers are white. Now you might ask, why would they have white feathers? And that's another communication method. So it bobs up and down. It's got white eye feathers, two communication methods. And so the male and the female probably want to keep in fairly close communication with each other at all times. In fact, when I shot this one, there was another one around. There was a pair. It was part of a pair, in other words. And you would think this water would sweep them down, but it doesn't. And there are two reasons. One is it actually pulls its wings in, it flies against the current, and also it grips the stones with its claws. So it feeds mainly underwater for insects, insect larvae, and mayflies and things like that, though it can catch flies or insects above water, but generally it doesn't do that. And it does not like crossing land. It flies up and down the river, but generally will not cross land if it can avoid it. Now sometimes they have to migrate to different areas, and they will do that, but their preference is always to be over water. Now this is a weaning off process. As I mentioned earlier, birds have to wean themselves off in a very short period of time. This is a youngster. It does not want to feed itself. Now, doesn't that remind us of our own kids? They cry, they want to be fed, and quite rightly too. But this is time for this one to become independent. And it's interesting, you'll see, by the end of the sequence, you'll see it looks very confident. Here it looks really, really badly lacking in confidence. By the end of this sequence, you'll see it's got there. It's found out that it can actually survive in the water. It's really amazing. Now this is not this bird making the sound, because I couldn't get the sound at the same time, so I had to incorporate a begging call from the Cornell Labs bird songs. So you can see it's constantly moving up and down because it wants the attention of the adults. And yet see the adults trying to persuade it to come down. You've got to walk down this stone into the water. See, this is the sort of thing that human beings do, isn't it? We have to wean off our kids, teach them to do things, and they don't want to do it. They want to just enjoy life without the effort. But there is effort involved. So you can imagine the reproduction rate's fairly low because lots of youngsters don't survive this sort of weaning off process. Now this is a sort of frustration. There's no food on that piece of greenery, but it's so frustrated it pecks away at that. Now it seems to me when I look at that water is pretty intimidating, so I can understand why that bird is not wanting to go down there. It makes a lot of sense to me. You know, with birds you have to be really, really lucky. I went down this canyon with a friend because I wanted to see this bird, but you never know where you can see these things. So I stopped. It was raining. I stopped, and darn it, way down there in the river was this bird. Just so much luck to have that. So I lifted up the tailgate and just put the video camera on it. See, it's finally got in the water and it finds that it can do it. Now I don't know if this is the only one that survived, because any one that I saw, there would typically be 2 or 3 youngsters. And in that canyon there's you usually see bald eagles. And I don't know if you know, do you know the story about Franklin, no, Benjamin Franklin and the bald eagle? Yeah. So some of you know, so when it was proposed that the bald eagle be the national bird for America, he did not want it to be that way for 2 reasons. One is it eats carrion, it's a carrion eater. Secondly, it's prone to kleptomania. That's to say, it steals some other birds. So one of the typical ones is ospreys. An osprey dives in and fully in and catches a fish. Well, quite often there'll be a bald eagle around. It'll harass the osprey, make it drop it, and by the time the fish has got back down to water, the eagle's there. It steals it. So Benjamin Franklin said, "That's not us. That's not America. But what is America is the wild turkey." But he was overawed. So this particular one was enjoying, I think, a Kokanee salmon. The Kokanee salmon is a landlocked sockeye salmon. With all of the dams and reservoirs we put up, the sockeyes couldn't get up there. So this particular one has become a landlocked sockeye, and it's much smaller than so this is an evolutionary step too, because this is a smaller, it's redder than the sockeye. About 2 or 3 years ago, we had an incredible eruption, so to speak, of Kokanee salmon. So normally, when we do a Christmas bird count, and normally we see 2 or 3 bald eagles in that particular canyon. That year, our team counted 67 bald eagles, and I went up there to look around afterwards, and there were not just eagles, but there were Kokanee salmon. They were sort of fin to fin, they were squeezed in. We haven't seen them. There's not even much water up there now, never mind salmon. So I'm glad Franklin was overruled, because I think it's a majestic bird. I just love it. But they take 5 years to become mature to get that beautiful, majestic white head. Interesting too, that was fairly shy. I was not very close, but I turned my back, and even though it was eating, it flew away. Adult predators know not to be too close to humans. So 5 years, so no sex, no family, and this. I was doing, with a group of other people, we do bald eagle counts on New Melones Lake every year. And I was up there in January, and we saw this first year one. And you can tell it's first year because it's got no white color. It's obviously not like the majestic one. And it was very, very, it was not shy. We could actually back the boat right up to it. So this is one is in its last year. See, it still looks a bit forlorn and pensive, I think, because it really wants to go and it can't find a mate. It's really frustrating for an adult that's very close to it. This is what it wants, of course, a mate for life. Now this is I was in a canyon about 3 years ago with my camera, and I saw these wrens, and I didn't know quite what was going on, but it turned out they were two youngsters that were being trained by their parents to become to fend for themselves. And what you're going to see is that an adult takes some food and gives it to this youngster, but the next time around the adult comes, she puts the food in the bill and takes it out again and flies off. And you'll see the youngster does not like it, but that's how the adults have to train their youngsters. I saw another interesting example of weaning off about 2 years ago. There's a bridge across that across the river that you're watching with the American Dipper, and there used to be a ponderosa pine, a snag, a dead one. And on the top was an osprey nest for several years until it blew down about 3 or 4 years ago in the winter. See, that's flying away. Doesn't like it. Very, very upset. So there was an osprey nest, and I was watching this one day, and the male came in with a fish, dropped it in the nest. There were two big juveniles ready to go, but they weren't quite ready to go. So the adult male dropped the fish in the nest, and then he casually picked it up again, dropped it over to the side, and went down to eat it. And I think that his message was, it's time to get out. And that's what they have to do. See, the youngsters don't know what to do, and they don't want to do it. They've got to be trained. Now the marsh wren is probably our champion singer, so to speak. It has about 200 sequences it can remember and sing. Before I tell you about that, though, the breeding season is a really concentrated season when you think about it, because you probably don't know, but birds' genital organs shrink when they finish breeding, and the reason is obvious: their weight. So they actually shrink. So when it comes time to breed, they've got to have a hormonal flow that grows the sex organs so they can actually have sex. So there's a lot of things that have to happen in a very, very short period of time. And I actually think that part of the reason that birds sing, one reason that birds sing, is to help to stimulate that hormone flow. So we know that bird singing is about territory, proclaiming territory, and about getting a mate. But I also think it's also about inciting that hormone flow. Now this one, the marsh wren is not just a prolific singer, he's a prolific nest builder. So he'll build up to 10 to 20 nests, and then he'll sing and attract the female, and the female will go around and select the nest that she likes. But he has another idea in mind too. We don't know what his mind is thinking, but once he gets one female bedded, so to speak, he's going to see if he can find another one. So there's an advantage in having several nests. This is down at Merced National Wildlife Refuge, and I spent a fair amount of time down there. So this is one of the nests that this guy is building, and what you'll see is he goes in with some fluffy material to help make this nest look really nice. So we always want to attract our females, don't we? But what I found quite interesting was when he's done his little bit of work there, he's going to go up to the top and sing. But you'll notice that he actually cleans his bill before he goes up top, because you can't sing and look good if you've got stuff all over your bill. You've got to clean it. So you'll see him actually clean. There he goes, look, he's cleaning his bill. I thought that was so funny. So as I said, they have about 200 sequences. What they do is they incorporate sequences from their neighbors too. So they're constantly changing their song. And the reason is they need to know their neighbors. So when they hear a neighbor singing, they need to know it's a friendly neighbor, it's not an interloper. But if they hear a sequence that they don't recognize, then they know it's an interloper. And these are feisty little birds. They'll get up and chase the intruder away. I never saw a nest at where this one got a female, so I don't know, but then I couldn't inspect all the areas where he would be. But with 10 or 20 nests, he should be able to get successful at some point, I suppose. Well, we know birds and animals use tools. And of course, gravity is a great tool, as you'll see with this glaucous-winged gull. This is also down at the Rengstorff House pond there. See, it takes up about 20 or 30 feet, and down it goes. And he knows to drop it on the hard place too, hard surface. There's the same grackle. You notice the grackle will walk past that gull close to it. He wants to get the food, but he knows that if he gets too close to the gull, he'll get slaughtered. The gull is not like the crow. It would really make mincemeat of him. I should tell you, I was at Hayward shoreline a few weeks ago, and I watched a bird doing the same thing. And initially it was making the mistake of dropping the shell onto soft land. And after a little while, it realized something wasn't right here. And out about 50 yards, there's a breakwater made of stones. And it was amazing to me, he actually took it out there and dropped it on the breakwater and broke the shell. Smart enough to know what was going on. So these birds are very, very adaptable. Now this is a very, very shy bird. It's called the American bittern. And it loves to be in the reeds. And it's got this very, very deep boom, so the sound can travel easily a mile because they're far apart from each other. That's not this one, by the way. I've incorporated the song from elsewhere from Cornell. But I was very, very lucky because this is, as I said, this is a very shy bird, and I was driving around this loop, which is only a drivable loop, and there was this bittern, and it came out into the open, as you'll see. And what's really funny, as you'll see too, they stand up like this in the reeds, so they're pretty well camouflaged. You look like a reed with all those markings. But what it also means is they're like this. So the eyes are looking this way, not the normal way. You'll see it towards the end. It looks at me, and it's looking at me in this really strange way because that's the way it's normally standing erect. But when I see this sort of thing going on, I wonder, what's going on in that bird's mind? It's going to have to make a decision, but how does it make a decision? It's not like a computer. It's not a rote decision-making process, and each bird will make a different decision. It would make a different decision in the same circumstances. So I often wonder, what is the sort of thought process that's going on? At some point, it's going to have to make a decision. See this strange way of looking? And eventually it did make a decision. It decided to fly. And that's when I wish I had a Prius car, because I had to start my car to move around because I had the wing mirror was in the way, so I couldn't take any more video. So I moved the car, and it quickly flew away. So as I said, this is a fairly unusual situation to see one of these out in the open, just like this. Bittern, B-I-T-T-E-R-N. It's called an American bittern. Bittern. It's a funny word to pronounce, actually, isn't it? You may have heard of something called adaptive radiation, and that's where birds in the same habitat evolve and adapt so that they're not competing all the time. See, the obvious advantage or example, or best example, would be the Galapagos finches. So you've got several different finch species on some of the islands, and they've adapted their beaks so they can feed on different foods, so they're not competing with each other. Well, shorebirds tend to be like that too, because they come to the shore, and you'll see lots of different species, and they tend not to compete, as you'll see here. It's really interesting. Now, so they'll have different body sizes, which means different prey. They'll have different bill shapes and so on. And this is up at this place called Ashby Spit near Berkeley. It's about a 200-yard spit that goes into the ocean. Lots of birds there. The whimbrel is an interesting bird. It migrates from the Arctic, Northern California, down to Tierra del Fuego. See, it's got that beautiful decurved bill. It's called decurve when it's curved like that. That's perfect for catching crabs in the water, and you'll see it doing just that. And when I watch these shorebirds working, I'm amazed at how quickly they make a decision. They make a decision about catching something, what's good, what's not good. See, it just happened, didn't it? I think it was aware of me and it was trying to run away from me. I wasn't that close, but I think it was an awareness of me that made it run. Now, if it was a larger crab, it would want to get rid of those legs. It would probably drop it on rock to get rid of the legs. But in this case, as you'll see in a moment, it swallowed it just as is. And I don't know if there's a right way round of swallowing a crab. I've never tried eating a whole crab, so I don't know. But it drops it a couple of times, so I think it's trying to maneuver it into a particular way round. If it was a fish, they would always want to put it down head first, swallow head first. There, gone. It's amazing how quickly that happens, isn't it? Now this is a fascinating little bird. It's called a turnstone because it literally turns stones with its bill, as you'll see. So you've got to watch this. This is just amazing. I'd never seen one of these till recently, so I couldn't believe it, and I was so pleased. See, look at that. Now, that's unusually big. See, it's looking for invertebrates and insects and worms, whatever is beneath that rock. And of course, underneath the rock, there's always something like that. Now, I took that first section down to 50% speed to take a look. It seems to have to use its body there. It's unusually heavy for that bird. It wouldn't normally go for one that big. See, that's... So, you think they're doing this all the time, so they're... bill must wear fast, it must grow fast. See, it's not competing with any other bird. No other bird is trying to do that. So it's got that particular role all to itself. I'm also interested in how these birds do run around. If I was running around the rocks, I'd trip, but they don't. It's just amazing how almost perfect they are. You'll have to tell me when to stop because I've got far too much material. It's like now this is real speed. I don't speed anything up, by the way. So when you see this running around, that's real speed. But it does interest me how quickly they make a decision. Something's edible or it's not. Yeah? Pardon? Oh, question? Yeah.
Kind of an interesting thing I saw on television. I've noticed it ever since I heard this, but predators whether it be birds or animals, have eyes in the front, and prey have eyes on the side. And if you start looking at it, it's kind of obvious why that would be, because the prey is always having to watch out for the predators, and the predators are trying to find the prey. But I just want to throw that out as kind of an interesting thing
it's
to
interesting.
notice.
Yes, you're right. Yeah. Yep. Yeah, if you look at a hawk or an owl or something, you're looking straight ahead. They're looking straight at you, that's for sure.
I had a quick question about the Kimbrel, because it looks so much like the limpkin that used to dwell along the riverbanks in Florida, and they ate snails. Do you know if they're related? His curved beak?
Yeah. No, I don't know. I could check it out, but I don't know offhand. What I've discovered is I know a lot less than I'd like to know, as you can imagine.
Sorry, Bert.
Oh, sorry, Carlos.
No, this is an extraordinary show that you are presenting here. Really, I don't know how you do that. In my whole long life, I have no chance to see scenes like that. So you must wait hours to get a picture like that. How do you do that? And what camera do you use apart from your iPhone?
Well, you know, bird watching does take time, and particularly if you're interested in bird behavior. So you have to know where to go to. You have to spend time there, and you have to be lucky. And you have to have all those things going for you. And but the camera, I use a semi-professional Canon video camera. And sometimes I use a tripod, and sometimes I don't. The shorebirds tend to be easy to photograph or video because they stay around the same area all the time. Birds that are in the trees tend to move around, so you can't use a tripod very easily, especially for video. So one day I was down there, and I actually took some stones. I think they had turned, and weighed them. You'll see them in just a moment. But it seemed to me as if the stones that were turning were typically 30% of their body weight. So it seems to be an amazing thing that they could do that. And again, you wonder what's going on in that mind. It's not a robot. It's not a computer. Something's going on. It's having to make decisions every moment. So that's what they look like. So it's a pretty light bird. Now if you go down to Point Lobos, you'll see this bird too. Now it's called an oyster catcher, but they don't eat oysters normally. They tend to eat barnacles a lot. Now barnacles are interesting because when the tide is up and they're at the same height as the barnacles, and the barnacles tend to, well, they don't tend, they gape, and they've got these tentacles that come out searching for food. So the oyster catcher's technique, so it's got one there. The oyster catcher's technique is to quickly push his bill in and cut the muscle that closes the shell. I think it's called the sphincter muscle. So when it's done that, then the barnacle's vulnerable to the bird. But what you'll notice a number of things here. One is it makes very, very vigorous attacks on the rocks and things where it thinks there's food. So again, we can imagine that the bill is wearing away and regrowing pretty fast. But also you'll see it makes very quick decisions. For instance, there will be a couple of times in the sequence where it can't open the shell, but it doesn't agonize over it. It realizes it can't open the shell and goes on. The decision-making process is incredibly fast in these birds, I've noticed. I think this is one where he uses a tool, in other words a rock, to wedge it, to try to open it. He won't open it. See, it looks like a pneumatic hammer there. See, he makes a quick decision, can't open it, away he goes to the next one. Doesn't waste energy on what's not doable. And you'll notice also they have this communication thing too. All the shorebirds tend to do things like that. And I wonder who he's communicating with. And if forgive me for saying he, and so I should have said she, shouldn't I? I should get in the habit of saying she. Then I would be more politically correct. So See, it looks like a lot of wear and tear on that bill at that point, doesn't it? I even wonder that it doesn't snap it off at sometimes, it's sort of probing around so vigorously. The sandling is a beautiful little bird. It's one of the sandpiper family. It's a very sociable bird, as you'll see. But they're really amusing because they feed in a totally different place than all the other birds you've seen. As you'll see, they follow the tide. What happens is when the tide comes in, it's bringing crustaceans and lots of little bits and pieces. So the sandling follows the tide on the way out, probing with its bill for those little things. It's really funny, isn't it? When they fly, they'll suddenly up and away in a tight formation, go around in a circle and come back again. And I did the unthinkable, the thing that you hate to do. I had a great movie of these birds doing this, and I managed to delete it.
How big are the sandpipers?
Like a sandpiper, pretty small. So how big? About that big? Very, very small. This bird's called the skimmer, actually skims over the surface of water foraging, as you'll see, and I think it's one of the most elegant birds, but it's quite a fascinating bird too. Now, you won't see another bird with mandibles that are different lengths. This is the only one that is like this. And when they're born, the mandibles are the same length because they've got to be able to grip food just standing still. You'll see it does it on the wing in just a moment. So it's the upper mandible is the one that moves, not the lower. So what it's doing is it's got its lower mandible in the water, and when it feels something, the upper mandible swoops down. You'll see it more clearly there. See how it's picking something out of the water? So it's doing it by touch. It feels something solid, and its upper mandible closes. There's also a fascinating aerodynamic thing they think there, because it's not really moving its wings, it's sort of skimming along and maintaining elevation. It's quite incredible. This is up at Redwood City, as a matter of fact. There's a water reclamation unit. So this is what we see. They've evolved different body sizes, different body shapes, so they can feed in different ways on different food in the same ecosystem. So it's really a non-competitive foraging technique that birds evolve over a period of time. Well, we might remember birds have been around a lot longer than human beings. So, for instance, the woodpeckers diverged from the rest of the birds about 50 million years ago. And I can't remember when Archaeopteryx was on the ground, but probably 70 or 80 million years ago. So birds have had a lot longer than we have to evolve all these different structures. When I was thinking about that, we've actually evolved several different structures, if you will, in humans over the years, haven't we? Because if you look at white people, the Mongolian people, from that area, we look at Native Americans, we look at the people from the Arctic Circle. I mean, we've got some major physical differences, and I wonder, we've only been around 6 or 7 million years. How many different species would we have, or subspecies of human beings would we have, had we been around 65 million years, and if we weren't such a traveling species, so we're mixed. You know, when you get populations that are separate, then they evolve their own characteristics. So it's interesting to think what would have happened, because we'll never know.
We do know there were many species of the genus species in Homo. Yes. And when the Cro-Magnon appeared, the others disappeared.
Yeah. Notably, I suppose, Neanderthals. Mm-hmm.
Just one. There were 40 of them. But the Neanderthals lived in Europe for hundreds of thousands of years. Yeah. And were kind of isolated from us until we then entered Europe.
Yeah. I'm a lover of the belted kingfisher, and what was interesting was we saw this one after that big storm in an area where I've never seen a kingfisher before, and I'd like to understand more about the dynamics of the base system, what happens after a storm, how the food comes in, because this kingfish was over there, and also there were brown pelicans, as you see in just a moment, that were foraging. So I'd never seen them in this particular area before, but then I hadn't been there before immediately following a storm. It was really interesting. This one's a juvenile male. If it was a female, it would have a rufous band around its belly. So this is one of the few birds where the female has more color than the males. He was a juvenile, obviously, because I got quite close to him, and yeah, that's a rattle that they always do when they fly. It's not exactly an attractive rattle, but it's a very distinctive one, isn't it? So the brown pelican, there's only one or two pelicans that actually dives for food. Most pelicans do what the American white pelican does, which is to strain water in through its bill in the water, but the brown pelican dives. Last year I was down at Capitola when there was a tremendous run of krill. No, anchovies actually. And there were about 20,000 sooty shearwaters and a whole lot of brown pelicans. They were diving in the water. It's incredible when you see 50, 100 pelicans all diving in the water. And I think everybody likes the owl. But what's this guy's chest when he does it? It really expands. Quite amazing. Now the female is larger than the male, and that's typical in raptors, and no one really knows quite why that should be so. But what's interesting is these birds are so powerful they can actually capture and carry a prey that's 3 times their weight. It's just amazing they can do that. You'll hear the Sandhill Cranes in the background. We're coming to the end, by the way, almost at the end. So there's a lot of communication that they perform with each other, keep in close touch. And those ears are not ears, they're just tufts actually. So that's why it's called great horn, not great eared owl, it's just horns. Now, the Sandhill Cranes wove a winter here, probably 2,000 or so, or maybe 5,000 down at Merced National Wildlife Refuge. Right now, they're probably 500,000 on the Platte River in Nebraska. In fact, I was tempted to go there this month, but I won't. I can't make it. But they're preparing to migrate up to northern Canada and Alaska to breed. And you'll notice when they land, by the way, they bounce. Always one bounce. But this is a species that's rather like the American pelican in the sense that it has 2 eggs but only produces 1 chick. So it seems like the second egg is an insurance policy. If the first egg is not good, then you've got a second chance. But they only produce 1 young. So if you ever want to see the sandhills, you go there in winter at to Merced National Wildlife Refuge for sunset. It's just a gorgeous sight. I was down there about a month ago, and there was probably a couple of thousand milling around the air. It's just an incredible sight. So busy.
Okay,
that's it. Thank you.
Okay, great.
Thank you.
Thank you, Barry.